Hi students, this is another video about graphing quadratic functions, and this is our vertex form. So you can see this is very different from the intercept form and how it looks. It's this quantity squared. So we would see this as some a value again, x minus h squared plus k. Now the vertex is h comma k. And don't get too worried about these variables. This is what you're going to see as you move on, especially in Algebra 2. You're going to see a lot of horizontal and vertical shifts, so left and right and up and down. For now, I'm just going to show it to you just so you kind of get used to seeing this. What we want to look for again is what would create a 0 in this term. You could even do a tiny little equation and say, what about this quantity in the parentheses equals 0. You could subtract 1 and x would be -1. I think probably you could look at this and say what number plus 1 is 0? It's -1. Now let's see what happens when I substitute -1 for x. So we rewrite everything except for now the input is -1. Now we already know this is going to become 0. That was the whole point, right? So it's -2 times 0 squared minus 5. 0 times 0 is still 0. Times -2, still 0. And subtract 5 is -5. So what this does is it gives us a special point, the vertex, which is at -1, that's the x, and the y, -5. -1, -5. So notice it's whatever makes this inside of the parenthesis 0, and then we scoop exactly what we see on the outside, whatever's being added and subtracted. Okay, so once we have the vertex, we can graph that. That would be fine, and we have x and y, -1, 1, 2, 3, 4, 5 down. And so that's my vertex, that's great. But we can't really graph the parabola with just this. So here is what I'm going to ask you to do. We're going to put -1, -5, the vertex, right in the center. And then we know that this is also where the symmetry line is. So what I can do is I can input a point just to the right and just to the left. So I can put in 0 and -2. What should happen is we should see some symmetry. I could also put in 1 and -3 and see even more symmetry. Let me rewrite this original. So y equals -2 quantity x plus 1 squared minus 5. And now I'm going to build my table. I'm going to do some substituting. So -2, I'm going to put in 0 plus 1 squared minus 5. And I'm going to do my order of operations. -2 times 1 squared, because 0 plus 1 is 1. 1 squared is 1 times -2 is -2, and minus 5 is -7. Okay, so 0, -7. Let's get that on here. I have a point right here. Now, because of symmetry, I can reflect it right over here. And guess what? Now you can draw your parabola. Now, I'm going to double check this because if I made a mistake here when I plugged in 0, I want to be able to catch my mistake. So I am going to plug in the -2 just to be sure. So again, we're just putting in for x. So this happens to both have a -2, but that's a coincidence. Okay. So -2 plus 1 is -1 squared. -1 times itself is +1. -2 times 1 is -2. And -2 minus 5 is also -7. So in fact, we do see that symmetry. But again, let's say I made a little calculation error here and I'm like, uh-oh, they don't match. We know they're supposed to. So then you can go back and find the mistake. Okay, so if we're given vertex form, we can pretty easily see what that vertex is going to be. And then we just build out a table to get additional points. And you could keep going. You could build out more points if you wanted to. But 3 points for what we're doing now is sufficient.